With the discovery of more and more rocky, terrestrial exoplanets orbiting nearby stars, there has been increased interest in studying these planets' atmospheres and surfaces. This is particularly valid for planets revolving around M-Dwarfs, whose characteristics may be best investigated with current observatories. Particularly, it is yet unclear what these planets' mineralogical makes up and how much solar irradiation they can withstand while still maintaining their atmospheres. There is no sign of any atmosphere on an Earth-like planet orbiting a M-Dwarf, the most prevalent form of star in the cosmos. This finding might significantly alter the direction of the quest for extraterrestrial life. Since M-Dwarfs are so prevalent, this discovery implies a large number of planets orbiting these stars lack atmospheres, making life unlikely to exist. In the course of an Earth day, this planet completes 2 orbits around its star. GJ1252b is both much larger than Earth and far closer to its star than Earth is to the Sun, making it both extremely hot and uninhabitable. The radiation pressure from the star is so strong that it can completely destroy the atmosphere of a planet. The Sun also causes Earth to lose some of its atmosphere over time, but volcanic eruptions and other carbon cycling mechanisms help to replenish what is lost, making the loss hardly perceptible. However, a planet cannot continue to restore the quantity lost when it is closer to a star. This is how Mercury is disposed of in our solar system. It does have an atmosphere, but it is very thin and is composed of atoms that the Sun has blasted off its surface. These atoms escape into space due to the planet's intense heat. Astronomers studied the planet's infrared radiation while its light was blocked by a secondary eclipse to establish that GJ1252b does not have an atmosphere. This kind of eclipse happens when a planet passes in front of a star, blocking both the light coming from the planet and light reflecting off of the star from which it is passing. The radiation revealed the planet's sweltering daytime temperatures, which are thought to reach 2,242 degrees Fahrenheit. The temperatures on the planet are so extreme that gold, silver, and copper would all melt. The researchers believed there is no atmosphere because of the heat and the alleged low surface pressure. The scientists came to the conclusion that GJ1252b would not be able to retain an atmosphere even if it contained a huge amount of carbon dioxide, which traps heat. Even if the planet contained hundreds of times as much carbon as Earth does, it would not have an atmosphere. It would begin to build up, but would eventually taper off and disintegrate away. The possibility that planets nearby M-dwarf stars might retain their atmospheres is further diminished by the fact that they frequently experience more flares and activity than the Sun. The state of this planet might be a warning indication for planets that are much farther from this kind of star. In the vicinity of the Sun, there are 5,000 stars, the majority of which are M-dwarfs. Even if planets around M-dwarfs are completely ruled out, there are still about 1,000 stars that are similar to the Sun and may harbor life. A planet may be able to keep its atmosphere if it is far enough from a M-dwarf.